the first numerical or the first case that we have seen in phase 1, right? So there are, we started with the two phase. Just to recall, I'll be just, we have started with the two phase method, in which we have, phase 1, in which we considered an artificial objective function, and we minimize it, right? So irrespective of the given numerical is a maximization or a minimization method, we minimize that artificial objective function. So after minimization, when we move towards the last end, that is the criteria will be getting fulfilled, that all Cj, all Cj minus Zj values will be greater than or equal to 0. For that particular step, if we reach that step, so I will be writing for step where all Cj minus Zj values are greater than or equal to 0, there will be three cases that will be arising. So what is the case 1? The case 1 will be, your W minimum value will be greater than the 0, and if that happens, stop at phase 1 only, and no feasible solution exists for the problem. No feasible solution exists for the numerical or the given problem, right? There will be case 2, right? There will be case 2 where your W minimum is equal to 0, right? And there is no artificial variable, right? There is no artificial, and there is no artificial variable amongst the final basic variables, right? So in this case, the optimal or the feasible solution exists, and then we are going to continue with phase 2, right? Nextly, there can be a case 3 in which W minimum is equal to 0, and there is at least one variable, one artificial variable amongst the final basic variables. So here also the basic fully visible solution exists, and we are going to continue with phase 2. Here in what is the difference between your case 2 and case 3? Here is that you can see W minimum in both cases is equal to 0, right? And there is here there is no artificial function variable, right? So it is okay. There is no artificial variable, but a serious case occurs when there is W minimum is equal to 0 and one artificial variable, at least one artificial variable is there. So this particularly is somewhat troublesome, not troublesome actually, but here we'll have to take an extra care so that the artificial variable should get eliminated, or we should make it to a 0. It should not reappear in our final optimal solution. That particular care we need to take. And nextly is our phase 2 only. So now I won't be telling you much about the phase 2, because I'll be when we'll be seeing a numerical, I'll be telling about the phase 2 directly, right? So we have actually seen case 1, right? So case 1 we have already covered in our last lecture, where our W minimum value came about to be 0, and we stopped at that particular point only, and we said that there is no feasible solution existing for that numerical, and there is no need of phase 2. Right now we are going to see case 2 in today's lecture, and it is similar, but what happens what next happens in phase 2 that we are going to see, right? So I'm hoping that you are recalling what what we have seen in the last lecture. And let's move ahead with our numerical, right? So we have a numerical, right? The question is, use two-phase method, two-phase simplex method or two-phase method to uh, question is maximize z is equal to 5x1 minus 4x2 plus thrice of x2 subject to twice of x1 plus x2 minus 6x2 is equal to 20. Then we have 6x1 plus 5x2 plus 10x3 less than or equal to 76. We have 8x1 minus 3x2 plus 6x3 less than or equal to 50. And we have x1 comma x2 comma x3 greater than or equal to 0. I didn't share that screen. Okay, just a second. Okay. Solve by two-phase simplex method. We have maximize z is equal to 5x1 minus 4x2 plus thrice of x3 subject to twice of x1 plus x2 minus 6x3 is equal to 20. We have 6x1 plus 5x2 plus 10x3 less than or equal to 76. We have 8x1 minus 3x2 plus 6x3 less than or equal to 50, and x1 comma x2 comma x3 greater than or equal to 0. So I think the given numerical is in the standard LPP format. So we do not need to convert it into the standard LPP format. So we are going to directly start with our phase one. In phase one, what we do is we go for artificial objective function. So I'll be writing artificial objective function can be given as, so minimize, right? In phase one, we also, irrespective of our numerical is a maximization or a minimization numerical, we always minimize, and we are going to write the objective function which is represented by w. Prior to that, we are going to concentrate ourselves upon the constraints. So subject to twice x1 plus x2 minus 6x3 is equal to 20. So that is the case with us. So what we are going to do here, we are now, it is an is equal to sign, right? So we'll be using the artificial variable. So twice of x1 plus x2 minus 6x3. We are not going to use slack variable because we have is equal to sign. So plus a1 is equal to 20, right? So second constant we have, where we have less than or equal to sign. So it is 6x1 plus 5x2 plus 10x3. To avoid the confusion here, instead of writing s1, I will be writing here s2, right? So here we'll have to add the slack variable as it is less than or equal to sign, and no, there will be no need of artificial variable. So plus s2 is equal to 76, right? Nextly, I'm going to write it as 8x1 minus 3x2 plus 6x3, right? Plus again slack variable s3 is equal to 50. I would have written s1, s2, doesn't matter, because it is just the name that we are going to give. But just to avoid the confusion, here I have written it as s2, s3 because that is related with your second constraint and third constraint. So that particularly will be reflected when we try to make a table. And lastly, we have x1 comma x2 comma x3 comma s2 comma s3 comma a1 should be greater than or equal to 0. So I'm hoping that you have understood how we have made or considered this uh, constraints. For objective function, it is very simple. Only the artificial variable will have a coefficient 1 and all the other will have it as 0. So it is 0 x1 plus 0 x2 plus 0 x3 plus 0 s2 plus 0 s3 plus a1. So this is our objective function, right? So what we are going to do next is that we are going to make a simplex table. So I'll be just using the next page to make a simplex table, and then we can solve this, right? So I won't be writing our objective function and the constraints again. I'll be just representing or doing it in representing it in the table format now. So we have the table as CB, we have CJ, and then basic variables. We have x1, right? X1, x2, x3, s2, s3, a1, and then we have a solution column. All right. So let's fill this cells properly. X1, x2, x3, s2, s3, a1, right? And here we have it as solution, right? So variables, considering the artificial objective function, so here it will be 0 0 0, and here we have it as 1, right? So now there are three constraints. That means there will be 3 rows, right? So first basic variable that we are going to consider from the first constraint is our artificial variable only, and then for second and third we do not have any artificial variable, so we are going to consider slack variable. So accordingly we have the coefficients 1 0 and 0. Then we can move ahead and represent our constraints in this table. So it is 2x1 plus 1x2 minus 6x3 plus a1 is equal to 20. So this was our first constraint. Nextly, we have 6x1, 5x2, 10x3 plus s2 is equal to 76. And third constraint that we had was 8x1 minus 3x2 plus 6x3 plus s3 is equal to 50, right? So this was our these constraints we have represented in this format. So what we are going to do is we are going to find out zj and then cj minus zj. So zj, it will be other values are 0 0 only. So here we'll have to write our first row as it is, that is 2 into 1 is 2, 1 into 1 is 1, 1 into minus 6 is minus 6, it will be 0 0 1, and here we have it as 20, right? So cj minus zj, so 0 minus 2 is minus 2, 0 minus 1 is minus 1, 0 minus minus 6 is 6, 0 0 1 minus 1 is 0, right? So what is this? This is a minimization function, right? So all cj minus zj values should be what? Should be greater than or equal to 0. Is it happening here? No. So all cj minus zj values are not equal to 0. Hence, you will have to iterate further, right? Hence, iterate further, right? So when we are iterating for a minimization function, what we do is we identify a key column, which is amongst identify key column first. So key column is to be identified in minimization problem for the largest value with negative sign in cj minus zj. So largest value in the largest value with a negative sign is minus 2, right? So this will act as a key column, right? And then we have it as we have to identify the key row. So we are going to consider the ratio column. So 20 divided by 2 will be 10. 76 divided by 6. So it is nothing but 38 by 3. Next it is 50 divided by 8 is nothing but 25 by 4. So for identifying the key row, we have to consider the minimum positive value in the ratio column. So amongst this, we have the minimum value as 25 by 4, right? So we are going to consider this as a leaving variable. So the leaving variable in our case is what? It is as 3. So let's reconstruct this table again. So here we have CB. Nextly, we have Cj and basic variables. That is x1, x2, x3, s2, s3. Then we have a1 and then solution, right? So this is solution x1, x2, x3, s2, s3, a1. Here we have it as 0, 0, 0, 0, and 1, right? So three variables, 1, 2, and we have 3 rows here, right? So which is the leaving variable s3 and entering variable is x1. So here we'll have to write x1. Here it is a1 and s2. So a1 has a coefficient of 1, s2 has a coefficient of 0, and here we have it as 0 only. So let's consider the key row first and find out the new values of the key row. So what will be the case? It will be 8 divided by no 8 divided by 8, that will be 1. Then it will be minus 3 by 8. It will be 6 divided by 8 is 3 by 4, right? Nextly we have 0 divided by 8 is 0. Nextly 1 by 8 0, and 50 it is 25 by 4. Similarly, for A1 row, we can write it. So it is 2 minus 2 into 8 divided by 8. So 2 minus 2 will be equal to 0. Similarly, it for the next thing, it will be 1 minus 2 into minus 3 divided by 8, and the value comes out to be 7 by 4. Nextly, the value can be given as new value can be given as minus 6 into 2 divided by 8, and that value comes out to be minus 15 by 12. Nextly, it is 0 minus 0 into 2 divided by 8, so it will be 0 only. Nextly, for S3 we have it as 0 minus 1 into 2 divided by 8, and that value comes out to be minus 1 by 4. Nextly, we have 1 minus 0 into 2 and, 0 into 2 divided by 8, and that comes out to be 1. Solution, we have it as 10 minus 25 by 4 into 2 divided by 8, and the answer will be coming out to be 15 by 2. Similarly, for the S2 columns, you can find out the value. The first value will be 6 minus 6 into 8 divided by 8. So it will be 6 minus 6, that is equal to 0. Next, it is 5 minus 3 into 6 divided by 8, and the value comes out to be 29 by 4. Next, it is 10 minus 6 into uh, um, 10 minus 6 into 6 divided by 8, and that value comes out to be 11 by 2. Nextly, we have 1 minus 0 into 6 divided by 8, that comes out to be 1. Nextly, we have it as 0 minus 1 into 6 divided by 8, and that comes out to be minus 3 by 4. And lastly, we have it as 0 minus 0 into 2 divided by 8, that comes out to be 0. Similarly, lastly, for the solution value, we have 20 by 38 by 3 minus 25 by 25 by 4 into 6 divided by 8, and that value comes out to be 154 by 29, right? So these are the new values. So what we'll have to do is we'll have to consider no we have to find out zj value and cj minus zj value. So zj value will be what? It will be 0, 7 by 4 minus 15 by 12, it is 0, minus 1 by 4, it is 1, and here it will be 15 by 2. So cj minus zj will be 0 minus 0 is 0, here it will be minus 7 by 4, here it will be 15 by 12, here it will be 0, here it will be 1 by 4, and 1 minus 1 is 0, right? So this is the minimization problem, and all Cj minus Zj values should be greater than or equal to 0. So this is not happening. We have a one value which is less than 0. So hence iterate further. Iterate further. Right. So I'll be just writing the new values directly, uh, and let's see what happens. Right. So the new values that we get are, so that you can check it out when you are solving this numerical at home. Right. So I want you to solve this numerical at home as well. X1, X2, X3, S2, S3, and we have it as A1 and solution. So according to the key row and the key column identification, what happens is that we get, one variable new, that is x2 variable instead of a1. So here x2 instead of a1 will be written. Here is x2 and here is x1. So here we have it as x1, x2, x3, s2, s3, a1, 1 0 0 0 0 0, and here we have it as solution, right? So x2 0, s2 is 0, and x1 is also 0. So the new values, that would have come, but I'm directly writing. You can cross check them at home. So it is 0 1 minus 30 by 7, it is 0 minus 1 by 7, 4 by 7, and it is 30 by 7. Here it is 0 0 256 by 7. Here it is 1. It is 2 by 7, minus 29 by 7, and it is 52 by 7. It is 1 0 minus 6 by 7. Here we have 0 1 by 14, 3 by 14, and 55 by 7, right? So this was no, the values that we get. So we can find out Zj values and Cj minus Zj values. So 0 minus, no, here all the terms, all the Zj values will be 0 only, because the coefficients in CB column are all 0, right? So Cj minus Zj will be, here it will be 0 0 0 0 0, and no, it is 1 minus 0. Yeah, it was 1 minus 0, so it was 1 here. Okay, 1, no, it will be 0 only, no? Yeah, it will be 0, and 1 minus 0 will be 1. Okay. So, no, here all Cj minus Zj values are greater than or equal to 0. Hence, proceed for phase 2. Proceed for phase 2. Now, phase 1 happens to be a bit simpler because there are a lot of 0 0 0 zeros that comes, and no, it particularly is easy. Now, what we are going to do in phase 2 is, no, I will be redrawing that column again, and I'll be making you understand. Cj, then we have basic variables. We have x1, x2, x3, s2, we have s3, a1, and solution. So now what is going to happen here is that now we are going to consider the original objective function, right? And the objective function was what? Z is equal to, right? So considering the all the variables, slack variables, and the what we can say, slack variables and the artificial variables, the objective function, the new objective function for phase 2, or the original objective function only is to be written here. So that was what it was: z is equal to 5x1 minus 4x2 plus 3x3 plus 0s1 plus 0s2 plus a1. So this is our original objective function considering the constants. So now here what we are going to do in phase 1, we are only going to deal with the artificial function. When we come for phase 2, we have to go for the original objective function. So here it will be x1, x2, x3, s2, s3, and a1, and we have to write the coefficients of these variables in the objective function considering the original objective function. So here it will be 5, here it will be minus 4, here it will be sorry, here it will be 3, here it will be 0, here it will be 0, and lastly what we have it as is 1. Right, and then we have it as solution. Right, so now no, particularly what has happened, in the first case, what we can do is we can directly now in phase 2, when we are going to consider the phase 2, we can directly eliminate the a1, because what is here, particularly which is this case, this particular what we have seen, this particularly is your case 2, right, where W minimum is equal to 0. There is no artificial variables among these basic variables, right? So there is no artificial variables among this basic variable, that is no artificial variable, no artificial variable. So what you can do here in your phase 2 is that you can directly eliminate the A1 column. So we are going to eliminate the A1 column, or you can directly not consider the A1 column. Why so? Because this is our case 2, and in case 2 what is happening, W minimum is equal to 0, and no artificial variable should, that is no artificial variable appears in the basic column. So if there is no artificial variable that is appearing, so here in phase 2 also there shouldn't be any artificial variable that is appearing in your this particular thing. Apart from that, all the values that you have in the phase 1 last table, right? So this particular table, this is the last table of your phase 1. All values are directly to be copied here. So I'm directly going to copy all the values, here, except the variable. So except this particular value. So what are my variables? X2, S2, and X1. So for this X2, what I have new coefficient, that is -4. राइट, सो -4 आई विल बी राइटिंग. S2 का कोएफिशिएंट कितना है? 0 ही है. और X1 का कोएफिशिएंट कितना है? 5 है. That I am going to write. So except this coefficient of the basic variables, all the values we have to copy from the previous table only. So for example, 0, 1, -30/7. Here it is 0, -1/7. Right. Solution also same, 30/7. Right. For S2 again, no, it is 0, 0, 256/7. Here it is 1, it is 2/7, and here it is 52/7. All the values from here phase 1 only I am just copying. So it is 1, 0, -6/7. No, we have 1/14. Then we have 3 by okay. Yeah, we forgot about S2 के लिए 0 है यहाँ पे. Then यहाँ पे 1/14 है. 1/14, and here we have it as 55/7. Right, so here all these values are only, upper values are only going to consider, and now we are going to move ahead and check for Zj and Cj minus Zj step. Right, so if we calculate the Zj, so here it will be 5, here it will be 4. The next value that we have is 90/7. Here we get it as 0, here we get it as 13/14, and lastly we get it as 155/7. Right, so here 5 minus 5 comes out to be 4, 0, -4, -4, and here particularly -4 and 5 into 0. So here it was minus, okay, -4, no, -4 into 1, yeah, -4 -4. So it will be coming out to be -4 plus 4, that will be 0. So 3, 3 minus 90/7. So it comes out to be -69/7. Here it is 0 minus 0 is 0. Here 1/4, 0 minus 13/14 comes out to be -13/14. Yeah. So now which is this, this particular objective function? Original objective function is a maximization type. So for maximization, all Cj minus Zj values should be less than or equal to 0. Is it happening? Yeah, it is happening. So hence this is the optimal solution that we have obtained. Right, so two-phase method particularly reduces your efforts. It reduces some steps, because in initially phase 1 what is going to happen, you are going to get 0, 0, zeros only. So most the calculation part, some calculation part can be avoided. And here in phase 2, basically only the care should be taken that the original objective function is considered, and the artificial variable, if it is the case 2, artificial variable is directly to be eliminated. So here we get an answer. So here you can say, no, your x1 value comes out to be 55 by 7, right? Your x2 value comes out to be 30 by 7, x3 comes out to be 0, and here the z max value comes out to be 155 by 7, which is this particular value, right? So this is how this particular problem will end. It is very simple. No, here we have seen the case 2 where the w minimum was coming out to be 0. This is w minimum, it is coming out to be 0, and there is no artificial variable among these basic variables, right? So particularly this is our case 2, and what we can do is, now phase 2, what I have done is I've considered the original objective function, and what next I have done is that other than the coefficient of the basic variables, all other column and the values I have copied. So except of these values, what I have done, all the values from the upper. So you can see, the first table, the first table on this page and the last table on this page is somewhat similar only, except your zj values. Why the zj values are changing? Because we have changed the coefficient of the variables in the objective function. So this is going to change, and this is going to change, right? So the circle marks that I have made are only the changes that are going to happen in the phase 2 table. Otherwise, the same values we are going to calculate, consider, and that particularly will be helping you out, right? So I'm hoping that you have understood this, case 2. In tomorrow's lecture, we are going to start with our case 3, right? And that will finish our particularly uh, what we can say, that will finish our simplex method. Then only one lecture will be required for understanding, 1 or 2 lectures will be required for understanding the duality, and that will finish your unit number 4. The only thing is that the practice is required. So I'm sending you one numerical for homework, no, and that is to be, then you can submit that particular homework. So immediately I will be sending, and there is one note that I have written. So the note is very, very important, and that will be, avoiding your confusion for this homework. So I'll be reading out the note, as particularly. So it may so happen that there is tie in selecting the leaving variables. When there will be tie in selecting the leaving variables, when the two ratio values are of similar thing, right? So two ratio values are same, and those happens to be the minimum positive values. So because of that, what will happen? The leaving variable, there will be tie in selecting the leaving variable. So at that particular juncture, if one of the variable is your artificial variable, select that artificial variable, because we don't want artificial variable in our optimal solution. So it is better to select an artificial variable at that particular instant and make that artificial variable to leave, right? So this is the first note, because this particular case will arise in your homework problem, right? And this is the generalized case, what I'm telling now. If there is a tie between the values which are helping us to identify the leaving variable, and if one of them is an artificial variable, consider artificial variable to leave. And tomorrow I will be telling you in the practical session, if the two variables, both of the variables are not an artificial variable, none of the variable is an artificial variable, so how to select that leaving variable, that I'll be telling you in the next case. But this is the numerical in which this will be helping you. So I've also written the note on the in the homework problem, so that you can understand that. Now, for the leaving variable, again, there is one thing that you need to understand. A leaving variable, how we select is that, we select a variable which is having a minimum positive value in the ratio. Now, what happens if the zero comes in your zero value is there in your ratio column? So if the zero value is there in your ratio column, that zero is also to be considered as a positive value only, right? So zero doesn't happen, no, it will not to be considered as a neutral value. So if in my ratio column there are 3 values, and one of them is a zero, so zero is considered as the minimum positive value, and that particularly will be no, so that the variable across that can be considered, no, the variable across that will be considered as a living variable, right? Getting this, right? So now you can tell me in the chat box, have you understood this no, numerical or not that we have solved today? I'll be stopping the sharing, and in the chat box you can tell me. We have understood. So no, basically try to solve the today's homework numerical, and that will be, you know, why I'm giving you an homework is that that will be helping you to know, gain the confidence. I'll be giving the answer of that also. The answer is with me, so I'll be sending the PDF copy of the answer on the group. On but I'll be, you know, happy that you solve your homework and, you know, submit it to me. If it is wrong, then it is okay, it doesn't matter. But no, the mistake you will be understanding when I'll be sending you the, you know, hard copy of the answers. So it doesn't matter if it is right or wrong, but I want you to put some effort and try solving it. Then only you will be understanding the numericals of systems approach. Otherwise, no, no, we do, no. There is a question that no, do we have the oral of systems approach tomorrow? We do not have oral, but we do have a practical. In practical, I'll be, you know, giving you the status about how, you know, the assignments, and then we'll be continuing with our practical session, right? So we are going to invest only 10 to 15 minutes in the oral as such of SSC, because there is a term work. So I'll be doing, or no, telling you how you have, know, what is the test status, and then we are specifically going to solve the numericals only in tomorrow's practical. So do not worry, right? So thank you for joining today. Complete the homework and submit it today only, so that I'll be telling you the answer for the numerical in tomorrow's session. Yeah, thank you for joining, and good day.